Hey, hello. Hi, guys. Hello. Hello, guys. Am I audible? Hello. Yes. Nice, 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 nice. Um, is my screen visible? Is everything all right? Is my screen visible? Am I audible? Hello. Yeah. So I'll wait for some 2 minutes and then I'll start. Okay. Yes. I'll wait for 2 minutes and then I'll start. Okay, guys. Um, one more minute and we'll start. So let me know if I'm not audible or if my screen is not visible. Yeah. Okay. Okay. Yeah. Yeah. So I'm going to start the lecture now. So today the lecture might be a little longer, right? So there are some good stuff to cover. So let's cover them, right? So we are gonna learn. So yesterday what we basically saw was that we saw data types operators, and we did not do these two things, flow control and methods and all of these kind of things. So yesterday we did data types and operators, right? Today we will do flow control, right? So flow control, arrays, strings, and all of those kind of things, right? So let's go ahead and start with this, right? Okay. So basically when we talk about flow control, right? When we talk about flow control, these are also basically known as control statements, right? And these are not specific to Java. This concept applies to almost all the languages. And guys, am I audible? Just give a thumbs up before saying whether this is audible or not, and if you are able to listen to me or not. Okay. Um, and doubts, we will see how I can address the doubts. Okay, at the end of the lecture. Cool. Right. Okay. Yeah. So here we have flow control, right? So we have control statements. Yes. So basically these are of three types, uh, right? So one is selective statements, right? Selective statements. The other is our iterative statements, and we also have transfer statements, right? Transfer statements. Okay. So what do they generally do? They are used to control the flow of your code. That's what flow control means, right? So the selective statements we generally have are if, else statements, and we have switch statements, switch case, right? And in our iterative statements, we have something known as for, we have do while, we have while, and we also have for each, for each, but this we will look into later. Okay. In our transfer statements, we have many, out of which we use break. We also use continue a lot of the times. We use return. We have so apart from these, we have 3 more transfer statements, and they are specifically for exception handling, and I will let you know what this is when we deal with exception handling. Okay. Now in exception handling, we have try, catch, and finally. So these are 3 more transfer statements, right? So these are the transfer statements statements you have, right? Like flow control methods, right? Selective statements and iterative statements and transfer statements, and in each of them we have if else, switch case, and in iterative we have for, do while, and for each we will learn when we understand arrays. Okay, there it is easier to understand. And then transfer statements, we can understand these 3. So break, continue, and return, right? So let's go with some examples. We will go with some examples for uh, selective statements, right? So some examples for this would be, so even before going to examples, we can break down our if else into again 3 more types. Basically, if we have if with else, okay, this is one type. Then we can have if without else, this is one type. And then we can have if else ladder, right? So these are the 3 types that we generally have, like A, B, and C, right? So the syntax is very simple, right? If I talk about the syntax, right, the syntax is very simple. What we generally write is, okay, so if we write a condition here, or like an expression. So the expression should provide a true or false, basically a Boolean expression, right? And we, whatever condition we write, right, if so here this part executes when condition is true, right? This is the condition, right? So if the condition is true, this part execute, and else what we have, this part executes when condition is false. Now again, the condition is this condition, right? So basically what we have is this, right? We have condition, and then condition, right? Okay, simple. Understood till here? If you have not understood, you can obviously go rewind and see what that is, right? So this part here, this particular part here is basically your A part, which is if with else, right? Okay, and generally this is known as the true block, and this is known as the false block. Okay, So false block is when condition becomes false and false gets executed. When this condition is false, this block will execute. When the condition, this expression or condition evaluates to be true, this block gets executed, right? Very simple. Okay. Right. And also one more thing to remember is that something like if 0 won't work. If 0 in Java, this is not possible. Right? Why? Why is it not possible? Because 0 is not equal to false in Java. And in the same one, 1 is not equal to true in Java. True and false are their own entities. Right? So true and false are their own entities. Okay? Right? So moving forward, right, I'll take a very small example. Right? The example would be, we will write a small class which is called demo. Right? In this small class, we have public static void main, and we are going to write string args. Right? And then we have int x equal to 10, and then int y equal to 20. Now, if x is greater than y, we are going to print, not print. So we are going to s out. Now, what is this s out? I am going to say max equal to plus x. Then else s out max equal to plus y. Right? What is this code related to? This is very simply max of two numbers. Right? Okay. Now here, when x is greater than y, here you will see that x here, the x here is 10, right? So here 10 is greater than 20. No. So this particular part is false. If this is false, then it will not execute this. This is not executed. Only this is executed, right? So 10 is not greater than 20. So I am going to print max equal to plus y. What is this plus here? This is basically just a string concatenation. Right? So what am I going to print? I am going to print. So the output basically would be max equal to, what is y? 20. So this is your answer. Okay. So your output would be max equal to 20. Right? So this is how it works. Right? If I had another condition here, if I had x less than y, right? Since 10 is less than 20, I would have printed max equal to 10. Right? This statement would get printed. Cool? Got it? Simple. Now let's move on. Right? So moving on, we have B, if without else. Right? We have B, if without else. Now in if without else, what do we have? It's very simple. It's just if condition. It's very simple, right? We will just have if condition on expression, right? And this will be there, and just execute this block. That's it. Execute this block. Right? So if there is code here and then code here, if we want to make sure that there is something in between, right? If we trigger some condition, if we want to make sure that we want to do something after if we trigger that condition, we will just write one single if, right? And so this is if without else, right? If this particular statement does not get executed, right? If the if condition is false, the control goes here, right? It will start executing from this place, right? Whatever code is here, right? So that's what, there is no else here, so it will not go to else part, right? So that is the main funda behind this. So something like if I have int x equal to 20, right, and if x is equal to 19, I am going to execute s out, um, s out, this is, and then plus x, right? Then I am going to execute, then I am going to s out x, right? So if I do this, what happens is, since since here x is not equal to 19, right? So here x is not equal to 19, right? So it will go to this place and this particular thing will definitely get executed, right? So even if we see that, let's say if we take this as 19, right, then what will happen, this particular thing will get executed, right? This will get executed and you will get the output as this is 19, and then you will also get 19. So this line will get executed no matter what. This line will get executed no matter what. This particular line is conditional, right? This is 19 or whatever is the x value is conditional. Cool, right? So only when this if condition is true, then we will execute this. Otherwise, it will not get executed, right? Okay, so that is the example for this. Now we have if else ladder, right? So we have if else ladder. So we have covered if else, if with else, and then we have covered if without else, right? And now we are covering if else ladder. This is if else ladder, right? So if else ladder, again, let's go with the syntax. It's very simple. Okay, now if we have if and then a condition, right, we will execute this block. Cond is true, this block executes. This block executes, right? Else, again, if I do one more if, cond 2, cond condition 2 is true, if this is true, this particular thing, right, then this block executes. Right, in the same way, if again, so this block executes, and I can have one more else if. I can keep on having else ifs, right? I can keep on having else ifs, and at the end I can also have an else, or this is also optional, right? So something like this. This is the syntax. So this is the syntax. Okay, now this is very simple. Okay, now this is known as the if else ladder, right? So a very good example for this particular piece of this particular thing is, I'm going to minimize this thing here. Delete. Right, so this is the syntax, right? So a very good explanation for this particular thing is, we can write a code, something which I think a lot of you already know. So we will again write a class known as demo, right? This is PSVM, public static void main string args, right? And then if we take int x equal to 10, y equal to 20, and then z equal to 30, right? What can we do? We can write something like if x is greater than y and if x is greater than z, then what I will do, I will s out system.out dot println, I will say max equal to x, right? This is concatenation. This particular part is concatenation. Max equal to string plus x. Okay, and then otherwise I will say else if y is greater than z, I am going to say print max equal to plus y. Else what am I going to say? I am going to say max equal to z. Okay, so basically this is what is this code. This particular piece of code is very simply this is max of 3 numbers, right? This is how you find max of 3 numbers, right? So this is the max of 3 numbers. Okay, now this is a very good example of an else if ladder, right? The logic is very simple. If x is greater than y, only then go and check if x is greater than z. If x is greater than y and z, then that means max is x. Else if y is greater than z, we have already established that x is not greater than y and x is not greater than z if it comes to this condition, right? So that means x is either smaller than y or smaller than z. So that means if y is greater than z, I can say max is equal to y. In the other case where we have an else, if we have already said that x is not greater than y and x is not greater than z, and we have already seen that y is not greater than z, only if either of these two conditions or these two conditions fail, then we will go to the else part where maximum is definitely z. That's it. So that is the logic for this. Cool, got it? Now whatever it is, this is pretty simple to understand, right? Let's move on. Okay, now okay, yes, so these are all about your if else. Your if else is all about this, right? Selective statements. You have if else is completed, right? We have the next thing that we have is we have selective statements, right? Switch case. Right, most of the people, they get confused with switch case. It's very simple, very simple, right? You generally have a switch, right, and then you have an expression or a condition, right, which has to match a case here, right, and the case will have some value 1 or like value 2, right, and then value 3, right? There are many things, right? And then you definitely have a default case. Now default case, now this case gets executed, this body, right, gets executed when the condition doesn't match any case, right? What do I mean by that, right? So if I name this as block 1 and this is block 2, if this is block 3, right, if the condition here, if the condition, what is this condition, right, if the condition here matches value 1, then block 1 would be executed. Okay, okay. In other case, if condition or expression, right, if it is equal to value 2, then block 2 executes. Very simply, right? That is what this particular thing is, right? Let's write a very small code for this. Okay, now I am just going to write a very small snippet of code, Again, you can use a small class. Again, this is a demo class, right? I can say I have again psvm string args, and then we are going to write int day equal to 2, right? If I have switch, and then if I switch on day, here one more thing, this condition here, whatever you have here, this need not be a condition. Can be expression, right? So this value you can provide a value, and that value has to match a case, right? And you will say case, and then you will give a number here, because this day, this particular day, that is, it is an integer, right? So the case will take a value, right? Here it will be like, if case is 1, right? For case 1, that means when day equal to 1. Here this means these two combined will mean that if day equal to 1, then execute this block, this particular block, right? So I am going to write something like s out Monday, and I'm going to close it, right? But I'll tell you what is the problem here. In the same way, if I do case 2, right, and I'll write s out Tuesday. If the day is 2, then it is Tuesday, right? In the same way, I'm going to close it here, right? For I can also do one more thing, which is I can compound the numbers. I can say for case 3, for case 3, for case 4, and for case 5. What I can do is I can combine these cases into one block, saying I can simply say other days, right? When day equal to 3, 4 or 5, these three conditions will execute on, will basically say these three conditions will so if any of these three conditions, right, if day equal to this is basically saying, this is like, you have to think of like this: if day equal to 1, sorry, one second, if day equal to 1, oh my god, okay, sorry, if day equal to 1, or if day equal to sorry, here it should be 3, here it should be 4, and if day equal to 5, right, then this particular block will get executed. Okay, so this condition is like a 3 OR case conditions. This can be also done, right? Now one second. Okay, I am going to decrease the size of this so that everything fits in one page. I am going to resize this thing, one second, give me some time. Cool. Let's move forward, right? And for if day does not match any conditions, right, I can obviously write default, right? If day is -1 or anything, right, if the days doesn't matter anything, then what I can write is I can write s out invalid. I can write invalid, right? And then I can close the switch case like this. I can write invalid. So this is the switch case code, very simply, right? And also one more thing is that if you say, if you have given this day, this particular day here turned out to be 2. So case 2 will get executed Tuesday, and what happens with switch case is that it will go and check for case 3 again, case 4 again, and then case 5. And for case 5, what it will happen, it will go and do S out. What happens is switch case, once you match one thing, right, it will keep on going till it finds a default. Once it finds a default, it will stop. So in order to stop it, what you generally write is also a break statement along with the same thing. Along with this, you also write a break statement. Now what does break do? Here for default you don't need break. So here break is optional. Break is not needed. Right? So what does break do? Break basically says that if this case is executed, if this particular block is entered, once you achieve a break, what it will do? It will not check for all of these places. It will come out of this switch case to this line here. Even like this line, if there is a print statement here, then it will print here, right? This print will be executed, right? So it will come out of this particular entire switch case. So that is what a break does. Break in any particular loop, so in switch case as well, whenever it sees a break, it will come out. So for example, now if day is 1, what will happen? It will go and check if day and case 1 match, right? Day is 1 and case here is 1. So for day equal to 1, I am going to print Monday, and I am going to break. So when I break, I am saying I am going to ignore all of this, come out. That's what. So if the day here, right, if the day here is 6, what will happen? It will check this, it is not matching, check this, not matching, it will check this, not matching, and it will definitely lastly go to default. Default is when nothing is matches, it will go here and just print invalid, and after this anyway nothing will be there. Anyway nothing is there, so you are going to automatically come out. So that is the reason break is not needed here, right? And remember by convention that you should mention default at the end. Don't mention default here or anywhere else, right? So that is the main thing, right? That is how you need to understand this. Okay, now from Java, from Java 1.7, which is Java 7, here in this part and in this part as well, like in this particular part, sorry, you can give a string here, string data, and here as well you can give string data is possible. So string equality is possible in checking something like this, right? So for example, let's very quickly write the code for that. So for example, if I do switch, right, switch, I will write some lang, and I am saying string, I can write lang equal to Java, right? Then I can write case C++, right? And I can say S out, lang is C++, right? That is how I'm going to write, and then I'm going to break. In the same way, now in default, I can say in default, I can just say S out, language is not recognized. Maybe something I can write. I can also write something else as well, right? And you can write break, or you don't need to, right? So this is how you have to explain and understand this, right? Got it? So that is how you understand this. Cool. Now let's move on to the next particular stuff, next particular thing, and the next particular thing is iterative statements. So the iterative statements that you generally have are, one second, iterative statements that you have, right? So the iterative statements that you have are so the iterative statements, the first one, right, you have the for loop, right? So for loop is a very important loop, so listen to this particular thing very carefully. Okay, If you have any doubts regarding the previous lecture, previous content, I will explain you during the doubt session, right? I will have a 10 minutes doubt session and then you can understand there. So first please listen to this particular thing very carefully, right? Here what you can do is you can write so the syntax goes as follows. You can write for, here there will be an initialization step, initialization step, right? And then you can have a condition here, right? And then you can have an increment or decrement here, right? And then this loop body. So this loop body is here. Now there is a little mistake on numbering, right? So this is 4 and then this is 3. Now remember very carefully, this you need to understand, okay? If you don't understand this, for loop is gone, okay? Now first step 1 happens only once, that's it. Initialization happens only once, okay? Happens only once. Remember this is a very big important point. If you don't understand this, then you will go very wrong in understanding for loop, okay? So what happens is, once initialization is done, this particular expression will never get executed again. This particular part, this initialization will never be done again. So once this is done, once I equal to 2 or 3 is done, then it will check what is the condition. If this is true, then it will automatically go to this body. No matter what, you will go to the body, execute whatever there is there in the body, then you will go to the updation. So this step, either increment or decrement that I have written, is an updation step, and this is obviously optional. This is optional, right? Optional. Actually, you know what? You can say 1 happens only once and 1, right? 1, 2 and 3. Remember this again. 1, 2 and 3 all are optional. All are optional. Remember this. This is very important. 1, 2 and 3. That means this particular thing, this particular thing, all of them are all optional. All of them are all optional. Loop body is not part of 1 to 3, so loop body is different, but all of 1 to 3 are optional. All of this particular thing, this particular thing, this particular thing is optional. So what you generally write, if it is optional, what do I mean by optional, right? The thing that I mean by optional is that if I write a loop like for, right, and if I close it, so a lot of people will think this is invalid, right? Okay, this is valid. In Java, this is valid, and this is an infinite loop. Okay, this loop will keep on running. This loop will keep on running. A normal Java loop will look something like this. A normal Java loop will look something like this. For int I equal to 1, I less than or equal to 5, I plus plus, right? And then you can just do s out I. What exactly will happen is that first I is equal to 1. Once I is equal to 1, don't care about this statement. That's it. Remove this statement from your mind. Now your entire game is this particular statement, and this particular statement. That's it. 2, 3, 4. That's it. Once this I equal to 1, that's it. This initialization statement, remove that from your mind. Is only used for one particular, once and only once. That's it. First initialization, right? This forget. Once I is assigned 1, right? Then I is less than 5, 1 is less than or equal to 5. True. If this is true, go ahead and execute this s out. Whatever is this print statement, s out I, right? What will you get at the end? here. So here the output would be, for the first iteration you would get s out as 1, and then remember you are not going to look into this at all. You are only going to look into this now. So once this is done, 1 is less than or equal to 5, true, you got system.out.println, 1 is printed here. Then you are going to look into this updation statement. It is saying I plus plus. I plus plus is equal to I plus 1, right? I equal to I plus 1, right? So this will get executed. Now I will become 2. I will become 2. This does not matter at all. It will only execute once. Remember, this particular part will only execute once. So this does not matter at all. Only once, and then you move, right? So this don't care, right? So you see that now I is 2. So 2 is still less than or equal to 5. Go into the body and then s out I. What is I? 2. So what will you execute? You will write 2 here. In the same way, now once this is done, body is executed, then go to the updation. Third step. What is the third step? Go to the updation. I equal to I plus 1. I plus plus is I equal to I plus 1. When I is equal to I plus 1, I becomes 3. Right? When I is 3, you directly go to this step. Right? I am telling you again and again, don't care about this step after the first step. That's it. You don't even care about this step. Once this is done once, right? Then you will only do 2, 3, 4. 2, 3, 4. 2, 3, 4. And 3 and 4 will only be done when 2 is true. So here 3 is less than or equal to 5. This is true, right? So now go into the body, print. What are you going to print? You are going to print 3. Now once 3 is printed, what is happening? Once 3 is printed, what will you do? Again you will go to the updation step. Once body is done, you will check if there is an updation step, right? If there is an updation step, what will happen? You will again do I equal to I plus 1, right? And then you will get 4. 4 is less than or equal to 5. Again you go in, then 4 you will print here. Once 4 is printed, again you will go here. Now I equal to I plus 1, which is 5. Now 5 is less than or equal to 5. This is true. Since 5 is equal to 5, it is asking less than or equal to 5, right? This is true. You will go in, print, right? You will go in and print 5, right? And now what you will do? You will again do I plus plus. It will happen again I equal to I plus 1, and then you will get 6, right? Now you go here. 6 is less than or equal to 5. Is it true? No, false. What will happen? You will come out of the loop and start executing code below this line. Here, whatever is the code after this, you will start executing. So the answer that you are getting is 1, 2, 3, 4, 5. That is what your answer is, right? Did you guys understand this code? If you did not, please go back and check the video. Okay, right? Yeah. So if I do a small change in this code, right? If I do a very small change in this particular piece of code, what will happen? We will see, right? If I say this particular thing, right? Since I said that all the conditions, all initialization, what did I say? Initialization, condition, and incrementation or decrementation, or whatever this updation step is, these 4 are optional. So here I actually have to write 4, right? 1, 2, 4 are optional. When I say they are optional, what do I mean? That I can omit them, right? If I omit them, right, here there is no, now there is, no updation step. Now if there is no updation step, what will happen? Let's see. I is 1. This is now, don't care about this. Once I is assigned 1, you don't care about this, right? Now I is less than or equal to 5. Yes, 1 is less than or equal to 5, right? Go and output, and then you will get 1. Print output. Is there an updation step? No, it will say there is no updation step. Again go and check this. 1 is still less than or equal to 5. There is no updation. You will again print 1, right? So you will go inside and then print 1. Again there is no updation step. Go here. 1 is still less than or equal to 5. Your I has not changed at all, right? If your I has not changed, You keep on checking the same thing and you'll keep on printing the same thing. This is an infinite loop here. Again, this particular thing, again, infinite loop. Right? To break, to make sure that this is finite, to make sure that you want to make sure that this particular thing is solved, what will you do? You'll write int I equal to 1, I less than or equal to 5. Let's say you don't want to give this a condition, right? You can say s out I, and you can also give condition here I plus plus, right? This particular condition you can give, and then this will print the same answer as the previous one. What is the previous answer which was running? 1 2 3 4 5. You can check it and it will work, right? It will print the body. What will it do? It will first assign I equal to 1, then forget about this, no, not gonna use, right? And then I is less than or equal to 5, 1 is less than or equal to 5, yes, right? Go ahead, execute the body, print 1, then increment I equal to 2 now, right? Once I is 2, you will go this place, there is nothing here, you will go and check this, right? Now 2 is less than or equal to 5, yes, true, go in, right? Go in, print 2, update I to I equal to 3. Now again go to this place to the updation step, nothing is there, go and check condition, I is less than or equal to 5, which is meaning 3 is less than or equal to 5, right? Again 3 is less than or equal to 5, go in, print 3, update I plus plus, I is now 4, right? Once I is 4, right? I will check this, right? There is nothing here, since here, so on so forth. You will see that because of adding I plus plus here, I am not going to not check it. I am definitely going to check it. If I add one more I plus plus here, what will happen? In this loop, every time I will increment by 2 times. So I in first iteration I will be 1, in second iteration I will be 3, in third iteration I will be 5, right? So your answer would be 1 and 3 if I had I plus plus here and I plus plus here as well. So something like that. So you need to take care of how looping is actually working, right? And also I said 1 is optional. I said this particular thing here, this is optional, right? If this itself is optional, right, I can also write something like int I equal to 1, right? I can write for I less than or equal to 5, I plus plus, and then I can write I, that's it, and this will print me an answer which is very similar to the previous one, right? Since this particular thing is not there, it is only executed once and then this is not even looked into, right? I already have an I here, so I is less than 5, again I is less than or equal to 5, yes, true, it will go in, print 1, then it will update, then it will check 2 is less than or equal to 5, go in, print 2, so on so forth, as I have explained you previously. That is what is going to happen, and you will get 1 2 3 4 5, right? So this is how you have to think about it, right? So this is all the scenarios that can actually happen for a for loop, right? Now let's go and check the so let's go and check the while loop. Right? So the while loop, in the while loop, what you generally do is, so the syntax, let's figure out the syntax. The syntax is that you do an initialization, okay, before the loop. Once you have an initialization, while there is a condition or expression, whatever they are, right? What are you going to do? You are going to execute the loop's body, right? And then you will also write the updation step here. Updation is also in this same step, right? What are all the things that are happening? One, check the condition, execute the body, and then updation. So it's a pretty straightforward looking loop, right? You do initialization, then you check conditional, then you do loop body, then you basically do updation. That's it. Pretty simple, right? Okay, now very simple, right? So let's take a very small example, and this I will not explain a lot because while loops are not used a lot. They are used but not a lot in the real world, right? So a very simple example for it would be int I equal to 5, right? And then I can do while I, so I can do I less than or equal to 5. I can print I, right? And I can do I plus plus, right? If I do this, my output, what will it be? Now I is 5, right? I have assigned as 5. Is 5 less than or equal to 5? True, yes, 5 is equal to 5. So this is true. I will print 5. I will increment I. Now I is now I equal to I plus 1, I equal to 6. Now it will go where? It will go check the condition now, right? Now I, now 6, is it less than or equal to 5? No, no, it is not less than or equal to 5. Then what it will do? It will come out of the loop and start executing whatever code is below this while loop, right? So the answer here, the answer that you will get here would be just 5. That's it, right? That is, this is while loop, very simply, right? Now so very small note that I am going to make here is, note is both for and while, right? Both for and while are known as entry control loops. Okay, entry control loops. What do I mean by entry control loops? Right, very simple. What do I mean by entry control loops? Right, you check the condition during the entry, right? Check condition before executing body, right? What do I mean by the body? The body is this part. Whatever is there inside this is the body, right? Or whatever is there is basically here to here is the body, right? So before even entering the loop, if you have a check, then that is a very good sign that it is a entry control loop. Now we have what? We have something known as the do while loop. Okay, very simply, what is do while? Again, it's now the only loop here which is exit control. This is a exit control loop. What do I mean by exit control? So condition check is made after body executes. That is, body executes at least once. Got it? Very simply, let's write some code very slowly so that we understand. Not even code, let's understand the syntax. Again, the syntax is that we will have a initialization, right? And then we will have a do, and then we will have a loop body, whatever this loop body is, right? Inside this loop body, we again have an update statement. After this, we will have a while statement, and then there is a condition that you need to do a check, and then there is a semicolon, right? This is your do while, right? How exactly this works is very simple. Now this is first one step. Once this step is over, this first one step is over, then you will only do this particular thing on and again, since the condition once till the condition is becoming false. Once this becomes false, you will come out and then you'll start executing here, right? So here 1, and then this particular thing is 2, this particular thing is 3, this particular thing is 4. You can see that the condition here is the last step, is literally this particular step, right? So this is the last step. Before that, you definitely will go and execute the loop body, and you will definitely go and do the update statement. So whatever is the body, you will definitely execute. This entire body gets executed at least once, and then the condition checks. Once the condition is made, once the condition check is done, then if the condition is false, then maybe you'll come out and you'll start executing. But if it is true, then you will go and start executing the loop from the starting, body from the starting, right? So that is how this works, right? So for this, I would expect you to write your own particular code to understand, right? Write a menu program, right? Write a hotel menu program. Okay, where the waiter gives the menu to the customer, and customer chooses the order, right? That's it. So this is what your small assignment is. Small assignment, right? So if you guys can do it, it would be very nice, right? And you have one more thing. Now we have one more thing, which is transfer statements. Right? The transfer statements that we generally have are, right? So hello, yeah guys, so you keep on looking into this, right? You keep on looking into this. I will extend the class, okay? I will keep on I will tell the class today. It will be a little longer, but hang on, and you will see that there is some good concepts that are being that will be taught, and the attendance sheet will be shared at the end of the class. So hang on there, and I'll also take the doubt session. The class will be a little longer, so please bear with me, right? If you want the concepts, right, you can bear with me. Cool. Now so the transfer statements, we generally, whatever transfer statements we have are very simple, right? So first one is break statement, right? So basically you use break statement to come out of switch. You have already seen that. Or to come out of logic inside any iterative statement. Any iterative statement means inside while, do while, or for loop. That is what I mean by any iterative statement, right? To come out of logic inside any iterative statement, right? So what will you do, right? So very good example that I can take is, right, I can write a for I equal to 0, I less than or equal to 10, I plus plus, right? I can do if I equal to, so if I equal to 5, what am I going to do? I am going to break, right? In other cases, I am going to just print I, right? If I just print I, right? So what will happen here, right? You will just up I equal to 0, then you don't care. Once this is I equal to 0, you don't care. Then I less than or equal to 10, yes, 0 less than or equal to 10. What will you do? You will check if you'll go inside this particular body. Inside this particular body, there is an if condition, right? Is 0 equal to 5? No, it is not equal to 5. What will you do? You will now not execute this body. You will go next line. What is this? Out. So you are going to print. What are you going to print? You are going to, your output would have, first you will go print 1, right? And then once you print, your body is over. Then after the body is over, it will go to the updation step. Updation step says I equal to now 1 plus 1, what is this? Is true. Now 2 is less than or equal to 10, that is true. Go in, start executing the body. In the first line there is I equal to 5. Is 2 equal to 5? No. If it is not, then don't execute this. Go out. So if you don't execute this, the next line that you have is you are going to print it, right? What are you going to print here? 2, right? The print statement is that. And then once you print 2, after this there is nothing. The block ends. Once the block ends, it will again go to the updation state. See that I am not even touching this state. This state is not useful at all. Once this particular I is assigned as 0, you don't care about this, right? So I am only doing 1 is done, then 2, 2, 3, 4, 2, 3, this entire thing 4. That's it, right? So now I will become 3. 3 is still less than or equal to 10. Go in. Once you go in, I is 3 equal to 5? No, right? If it is not 5, then you will go and you will not even care about this statement. You will go and print 3. You will go and print 3, right? Once you will print 3, there is nothing here. Go here, do I plus plus, I equal to I plus 1, which is I equal to 3 plus 1 equal to 4, right? 4 is less than or equal to 10. This is true. Go inside the body. Here the first part is 4, is it equal to 5? False, right? Don't care about this body. To go to this next line, you will print 4 here, right? Once you print 4 here, then again, since there is nothing here, go to the updation statement. I equal to I plus 1, which is I equal to 4 plus 1, which is equal to I equal to 5, right? Once I equal to 5, you will check 5 is less than or equal to 10. This is true. Here you will check 5 is equal to 5. Once it is equal to 5, what you will do? You will get to this particular line. Once you get to this line, what will happen? You are saying break. When you say break here, no matter how deep it is inside the loop, you definitely come out of the entire loop. Whatever the fur is, whatever is the nearest fur to this break, you will break out of that loop, right? You will come out and you will start executing from here. So your answer that you actually get is this particular thing, right? Your answer that you get is 1, 2, 3, 4, 5, right? Got it? Simple. Now, if you don't understand any of this, you can obviously go back and watch the entire video, right? Okay. Now, the second thing that I'm going to tell you is continue, right? Continue, right? So in continue, what you generally have is that you have a for loop which has I equal to 0, I less than or equal to 10, I plus plus, right? And then if I equal to 5, right, I am going to say continue, right? And then I am going to print, right? I am going to print I, right? So what do you think my answer here would be? My output here would be very simply, let's analyze this code, right? What I am saying is I is equal to 0, done. Forget about this. Once I is 0, forget about this. Delete this from your mind. Remember that I started with 0. That's it. Now I less than equal to 10. 0 less than or equal to 10. True. Go and execute this body. In this, if I equal to 5, what is it? I equal to 5, right? 0, is it equal to 5? No, right? It is not equal to 5. Go and execute this. So 0 will be printed. 0 will be printed. In this particular case, once this is printed, it will go and check next line. There is nothing. The block ends. Go here, do the updation. Now I becomes 1. Once I becomes 1, go here and then check 1 less than or equal to 10. True. Once it is true, go and execute this body. In this body, the first statement is 1 equal to 5, right? If it is equal to 5, then only this block can be executed. It is not equal to 5. Then go ahead and execute this. What is the output here? Output would be 1, right? And so on. This will keep on happening, right? And you will print 2, you will print 3, you will print 4, right? and after you print 4 here, once you print 4, you will go here, you will say I equal to I plus 1, right? I will become 5. 5 is still less than or equal to 10, right? This is true. Go inside this particular loop body, and then this I is equal to 5 will be true because 5 is equal to 5. What this continue will do is, this continue will skip all the execution below this, right? Whatever is the execution, let's say there are 100 lines here, not only as out, there are 100 lines after this particular if condition and this continue, right? Once all this execution will be skipped, completely skipped, and then it will go to this line, this particular updation step, right? So you will not even print, you will not, because of this continue, right? Because of this continue, right? 5 is not printed, right? So that is the main reason why you generally use a continue. Now because there is continue, what will happen, this entire thing is fixed, skipped, and then you go to this. Now I becomes I plus 1, which is equal to 6, right? 6 is still less than or equal to 10, right? True. Go inside the loop. 6 is equal to 5. This is false. Don't execute this. Print 6, right? Now till 6, 7, 8, and then 9, and then 10, right? You will keep on printing. Once your answer, once you have printed 10, you will go and check, and you will increment I to 11. Once you have made it to 11, 11 is not less than or equal to 10, right? You will get out of the loop, right? So continue basically works like that, right? So this is what your answer is, right? So this is how you can definitely get your answer. Now before moving forward, I'm going to explain you a very little concept. Okay, are you okay? So a lot of you guys are still here, very nice. So I'll keep on going. Okay, the class will extend maybe for, let's see, if I can complete, let's see what I want to complete, right? I'm going to teach about method invocation and all today, right? Once method invocation is done, I am going to stop the class today, right? Okay, and then I'm going to take arrays and strings in the next class, right? Okay, so yeah, so what I'm going to do here is I'm going to explain you how methods work and what are call by value and call by reference, right? Okay, so that's what I'll tell you, right? Okay, so before even that, there is a very small concept of how to take input, input in Java, right? How do you take input in Java? Very small, very easy concept, right? Okay, now let's see. You generally have something called the java.util package. Okay, this is a Java package, where we have scanner, right? And this is this scanner that you have, right, in the util package, right? You will just import this. You generally import java.util.scanner, right? Once you import java.util.scanner, what you would do is that you will just write like a class, let's say scanner demo, right? In this class, you will have public static void main string args, and then what you will have, you will create a scanner object, scanner s equal to new scanner, right? The scanner object actually takes in one particular object, which is known as system.in. Now till now, what you have seen till now is that you have always seen that I write something like I'll say I'll gonna explain this here, right? I write something like s out, right? This sout is very short form for system dot out dot print, right? What here what you need to understand, that this system dot out is the output, which is the monitor now, right? And we also have one more thing, which is system dot in, right? Since we have an output object, why not also have an input object? We have an output object, we can have an output place, right? We can also have an input, and the input in this case is a keyboard, right? And this keyboard you have to pass it to the scanner, is what I'm saying, right? This particular keyboard object, you are passing it to the scanner. You can bind the input and output to anything, right? For example, if you say that I want a system.in, which is not a keyboard, maybe I want a mouse as my input for now, then it will take mouse coordinates as this. You will have to scan mouse coordinates using this, right? So something like that, right? So I'm not saying that both are going to fixate it to output as monitor or output as input as keyboard. The system.out can also sometimes point to printer, right? Whatever you want to print, you can use system.out maybe to print it on a printer, right? So something like that. Okay, so what I mean is, so once you have, so for now, if we keep the dialog till like input as keyboard and output as monitor, right? So what will happen is, with this particular s, right, what we can do is, we can obviously use something known as s dot nextInt function, right? We can use s dot next float function. We can also use s dot next function. We can use s dot next long function. We can use s dot next char function. We can also use s dot next double function, right? We can use these many things, right? We can use more, there are many, but each of them have a very specific functionality. If you know that your input, if you know that your input is all integers, you'll use s dot next int, and this s dot next int you have to store it in an integer, right? If you know that your integer, if you are going to get a float value, you use s dot next float, and you will have to store it in a float value, float y, right? If you know that if you are going to get a string, and it should be like space separated. If there is a string, if you are inputting abc, right, and then def, right, then this particular thing will store def, right? Got it, right? So sorry, not def, this particular thing will store abc, right? It will only take till, it will only take till it will only take till, if I have abc def, right, it will only particularly take abc, that's it. It will not, okay, one second, it will not take def, right? def is ignored. If you do one more next int, then def will be taken. So that is what you need to understand. Cool. Let's move on. Next long, you will get a long answer, and then you have to store it in a long a, right? This is very simple, right? The naming itself is so simple that you can understand. Char b, right? Next double, you will get a double. And you have to store it in a double, right? You can obviously do typecasting, and you can do whatever you want with that. But if you don't want to lose the input, then you can obviously do. A very good example for taking an input is basically, you can use system.out.print and just say enter an integer, right? If you just do enter an integer, then you can just say int I equal to s dot next int. And what is this next s here? It's a scanner object, this particular thing, right? It's a scanner object. Now for now don't understand what is a scanner object or anything, what is this syntax and all. This is the syntax to create an object, that's all you need to understand. And then system.in you have to definitely pass whatever is the input, or whatever, wherever you want to write the, wherever you want to scan the input from. This can also be like a file, right? This can also be anything else. In that file you are now scanning. Since you gave system.in, it would be it would be your terminal, whatever you have given it in your given from keyboard in your terminal, wherever you are running the program, that becomes your natural input, right? This here also can be a file, right? You can scan a file as well, right? Okay. So I'll give you one more small assignment, right? One more small assignment, right? Very small assignment would be to write a program to take to take a menu to add, subtract, multiply, divide and mod any two numbers, right? See, the number should be dynamic, that means they should be inputted from the from the keyboard, right? If you write this program, then it would be very nice for you to understand most of the stuff. Now I'm going to explain you so if you guys are up for it, right? If you guys can share a like, right? Share this video and then everything. I am going to teach you something very deep. This is the last part of the class. This I will explain and then we can take leave from the class, right? This particular thing is very important for you to understand how functions are called, how this particular thing is working, right? So hang on guys, it will be done in more 15 to 20 minutes, and then you can ask doubts, and then yeah, we will wrap up the class. Cool, right? Now okay, right, let's move on, right? I'm going to talk about how, right? I'm going to talk about how methods work, right? Okay, now let me say for now that don't care about what are there in the syntax, just care about the concept that is there, right? Don't care about the syntax, just care about whatever is the concept. Cool. Okay, now let's move on, right? If I have a class, right, I am going to say method demo, the class name, right? Whatever is the method demo, I'm going to say I'm going to write a static method here. It doesn't matter, right? For now don't care about whatever is static or anything, right? I'm going to say static void print1, and then this print1 just prints let's say print1, right? And then you have static void print2, right? And then I'm going to say as print2, right? Once I do print2, now before even printing 2, what will I do? I say I am going to write I'm going to call print1, I'm going to call print1, right? And I am going to say this is it, and then in static void print3, what I am going to write is print2, and then I am going to say out print3, right? Once this is done, I am going to write a public static void main, and this has our string args, whatever these are, right? We have a string args, and then what we are going to write is, right? Okay, I'm going to minimize the screen so that all of you guys can see it, right? So if everything is visible, just go ahead and subscribe to CodeSprint, right? So string args, once you have string args, right? What is this? What can I do? I can obviously go ahead and I can call print3, and then that's it, if I call print3, right, if I call print3, if I do make a call to print3, what exactly is happening is what I'm going to explain you, right? If I ever call print3, what is exactly happening, right? In general, now listen to this very carefully or you will not understand anything moving forward, right? Whenever we have a program, right? So for example, if I wrote add.java, right, this program is known as a program in the disk. In the disk it is known as a program. That means in the disk it is known as a program. That means in your hard disk or your SSD, okay, on the disk this Java file is just a program. Now once you start running it using JVM, which is your Java virtual machine. So how do you run this? You will just do javac add.java, right? Once you do javac add.java, what will happen? Once you do javac add.java, you will get a compilation file, right? Then you do java add, right? If you do java add, this is where you are running the program. When you run the program, your system generally has your RAM, which is the random access memory, right? In this RAM your program is loaded, right? And this program when loaded on the RAM, program on the RAM is known as a process. Remember this. This is very important, right? This particular thing is very important. Program on the RAM is a process, right? If you have your RAM, in this RAM, this particular portion is now your add program, right? This add program is now a process. When it sits inside the RAM, it is now a process. Now in this process, now this process also has a structure to it. In general, a process basically looks like this. Remember this, very important. Okay, in general, a process looks like this, right? And then you have the code section, you have global / static variables here, right? This is also known as a process. Your process in the RAM looks like this. The code that you have written generally resides in this particular code section, okay? And the stack that you have always heard of is this particular area, right? This particular area is actually shared between your stack and your heap, right? This particular area, this is a shared piece of memory, okay? This is a shared piece of memory, right? In this shared memory, whatever you see, and all your static variables. Now I'm going to explain you static and global later, but for now understand that all your static and global variables are going to reside in this particular area, right? So whenever you call a function, whenever JVM calls a function, for that function it will use this particular shared memory to store each and every function record, activation record. Each and every function is stored as something known as the activation record inside this particular stack. And how does that stack look like is this, right? Now I have called the print3. What exactly is happening before this, right? We have the JVM is the one that is controlling the process, right? Inside this JVM, so think of this as the JVM stack, this as the stack for the JVM. The process is run So this stack, I'm talking about this stack here. Here, this is the stack I'm talking about, right? What exactly is happening is JVM will call what? Will call the main function, right? Once main is called, inside main at line number 1, right? At this is line number 2, which is nothing. There is line number 1, right? In line number 1, once main is called, so this particular thing that has been pushed by JVM, first of all, this particular thing that has been pushed by JVM is known as activation record, right? Okay, and once this is pushed, what happens? That once this is pushed, what happens? Main will execute from line number 1, whatever this line is. Print 3 is executed. Once print 3 is called, here. Once print 3 is called, print 3 whatever is called, it is again pushed onto the stack. This particular stack that you see here, it should be pushed onto the stack. And here in this area, what you will see is, you will write when you get back, you have to start from line number 2. You have to start from line number 2, right? When you get back, you start from this particular place. When you get back from call of 3, once print 3 is over, you will get back to line number 2 in the main function, which will be this particular line. Once you get back here, you will be out. But since print 3 is still not complete, you will go and check whatever is there in print 3. What is there in print 3? Print 3 first line it has. Now again, in print 3 there are 2 line, right? In print 3 there are 2 lines. In print 3 there is first line is print 2, right? What will happen? It will now push print 2 into the stack, right? Once it pushes print 2, then it will maintain whatever it has to come back to. What is the element that it has to come back to? Is this particular thing, right? Line number 2 in print 3, right? Line number 2. Here also it will maintain what is the line number that it has to come back to, right? In print 2 now, once you have called print 2, in print 2 now execution starts again. This is print 2. In this print 2, right, you have first line, second line. Here in the first line there is print 1. Now in print 1 it will go to this particular place, and then it will again call print 1. Once there is a call, it will create an activation record, this particular thing, and then push it onto the stack. Once it is pushed onto the stack, right, print is called. Before even creating this record, it will definitely store where to. Once I come out of this, once this particular print function is over, I will get back. Once I get back, where should I start from, right? Where should I start from? I should definitely start from line number 2 here in print 2, right? So that line is going to be written here, right? And in the same way, once we go into print, right, what is print? Here we will go into print here now, which is, so this is print 1, right? I am going to write it as print, right? So in this particular print, we are going to, what are we going to do? We are having only one line, and this one line is going to s out. What is s out? S out is a function. S out is basically short form for system dot out dot print, right? Print is what? Print is a function, right? Again print will be called, but this time it will be system dot out dot print. So the print there is different, and the print that we have written is different. Print will be called, and here when you get back, you will get back to this line, right, which is line after this line, which is the end of the block, right? So you can write end of block, right, E, right? Once you have done this, you will print. What are you going to print? You are going to print print 1. Print 1 will be printed to the output. Once that is done, what will happen? It will, once it is completed, it will pop, right? It will pop out of the stack. Once this pop is done, you will go back to this line. In this, where do you have to go? To the end. Where is this end? This part is the end, right? What will happen? Once you reach an end, you will again pop. Once you pop, you will go to this place. In this activation record, you have to get back at line number 2. In line number 2, where is print 2? In print 2. Basically, in our print 2, you have to get back at line number 2, which is this particular line. Particular line. Now again, this will call s out, right? S out. So if it is calling s out, right, this particular, once this is popped, right? If this is popped, that doesn't mean the memory is over, right? You can again push to the same stack. If you push to the same stack, right, what will happen? I'll create it here, right? I'll create it here. It will go and call s out, right, whatever the s out is, and it will push the function here. Then it will print what? Print 2. It will print 2 and then pop get back. Once you get back, since line number 2 is over, here before even going, your line number 2 got over, right? Line number 2 got over, and here also it got ended, and this will get popped. You will go back here. Once this gets popped, right, you will now go to print 3. In print 3, you will have to go back to line number 2, right? In print 3, this is print 3, you'll have to go back to line number 2. Now since this is also a system call, it will again push back into this particular whatever stack that it is using, right? Since there is no space here, I am going to write it below here, right? And what is it going to push? It is going to push s out, and the s out that it is going to push is with print 3, right? Whatever it is, it will execute, it will pop back. Before you get your answer, you will get print 3 here. Print 3 as the answer. Once you get print 3 as the answer, it will pop, it will go back. Now before even going back, this was always getting executed, right? You need to remember that this always gets executed, E, right? Once this is ended, right, here, once we have reached the, in print 3, we have reached the end. We will go out. We will now pop out of this particular thing. Once we pop out, we go back to main. In main, we are going to come to this particular position, right? This particular position, there is no line 2 in main actually, right? So there is no line 2 in main. You can say that is, so in the beginning it just started from end. You can say that, right? In the beginning it started from end. So now once main is also done, you can pop that as well, right? You'll pop it out, you'll come out of the stack, and this process will be destroyed. Once this entire thing is done, this process will be destroyed. Now intermediary values that you have stored here, the places to where you start, this thing is known as the stack pointer. Okay, this entire thing is known as the stack pointer. Cool. Did you guys understand all of this? I understand that this entire thing, this explanation is extremely complicated, but if you guys got through this, then you can understand methods very well. You can understand how methods actually work. Okay, once this entire thing is understood, right? Okay, I think I should stop the explanation right here, because after this, if I teach you anything, it would be too much for you guys to understand. So I'll stop this now, and I am going to take some doubts, right? Guys, I am going to take some doubts. So this is how your stack works. Okay, I am going to start with how methods, how you can pass by value or pass by reference in Java in the next lecture, and also we are going to learn about arrays, strings, and all of those kind of things. So now you can now you can ask the doubts, right? And did you like the lecture today? Right, now you can take the, you can basically take the notes. I will definitely share the notes, right? I'll share the notes in the group. If you guys have any doubts, just ask me right now and I'll explain. I'm going to wait for like till 5 to 10 minutes, and then I'm going to end the stream. Yeah, just ask me whatever the doubts you have. I know today's class went for 1.5 hours, but these concepts, trust me, uh, these concepts are asked for a fresher, and they will be so you will definitely be judged on these kind of things. Oh, okay, okay. You couldn't join the group. So what I will do is tomorrow, if you attend the same thing, I will make a GitHub repository, and I'll upload the notes there. Okay, I'll upload the notes there in a GitHub repository. You can download the notes from there. Okay, and I will share the link in the live chat here, right? Okay, and one more thing, I'll give you the attendance link right now. Wait for 2 seconds. 1 second. I'll give you the attendance link. All right, 1 second. I'll just add a window capture. All right. mm, right. Okay. So I'm going to add a window capture for now, and I'm going to share. Uh, right. I'm going to share the attendance link right now. Okay. 1 second. 1 second. I'm just gonna share the attendance link to you. Okay. Here. So this is the attendance link. Go ahead and fill up the form. Cool. And I'll definitely share these notes. Okay. I'll tell my team to share these notes with you. Right. So there is a lot of things covered today. If a lot of you did not understand, go through the notes again, go through the lecture again. Right. There are a lot of important concepts that I mentioned today, and you can obviously understand whatever you want to understand here. And yeah, I mean, I'll make a GitHub report today, and then I'll share it to you tomorrow. If I hope most of you join tomorrow, and then you can understand, right? And if you guys have any doubts, just curly braces in switch cases, even though it will execute until break. Actually, it is not. Hi, Srinu. In like curly braces are not necessary in switch case statements. Okay, and statements, right? So what you can do is, you can always test it on your system, right? Write some code on your system, and definitely you will see that you can understand. Okay, right? Yeah. Hello. Yeah, guys. So yeah, so there are, so if you guys, I'll wait for 2 more minutes, and if there are no more doubts, I'll just end the stream, right? I'll wait 2 more minutes. Cool. Okay. If you guys want to, you can still ask doubts and go ahead and check it. Yeah. Okay. um, and obviously you can ask doubts tomorrow as well. If you have any doubts from the programs that I have written, you can go ahead and write these programs in your system. So the programs that I have might have written might have some syntactical errors. What link? This link is not working. Yeah, it is. It is working. No, I just opened it and it is working. Yeah, link is working. Yeah, I will let the team know. uh, so I let the team know if you have an issue with whatever this link is, right? I will let them know, let the CodeSprint team know. Yeah, so yeah, you use whatever email account you have registered for the course, right? Then it will definitely mark your attendance for sure. Yeah, and you can definitely, yeah, you can use the email account, and then it will mark your address. Sorry, it will mark you as attended the class, right? Present. And yeah, so most of you, please, all of you, just please practice. Go ahead and understand the concepts that I have written today. There is a lot of things that I covered today, and deliberately I took a longer class because there was a lot of things to cover, right? Yeah, and yeah, go ahead, and if there are any doubts that you guys have, you can obviously reach out to me. I'm also going to write my LinkedIn here so that you guys can understand. So my LinkedIn, I'm going to write it on the top. My LinkedIn is, sorry, I'm going to write here. So my linkedin.com/in/ch Sriram, right? So this is my LinkedIn, right? So this is my LinkedIn, right? This is my profile. One second. So yeah, so this is my LinkedIn. Okay, you can obviously catch me there. Okay, yeah, so I'm going to end the sprint. Bye and have fun. Sorry, not the end the sprint, end the live stream, and don't forget to subscribe, share, subscribe. Bye. Thank you. Amma.